So in our first example, we are going to again use our exponents rule to simplify. We've got the same base, so we subtract the exponents. So the answer will be in the denominator because that's where my bigger exponent is. So 3/4 minus 1/4 is 1/2. And 12 divided by 12, of course, gives us 1. So we have a 1 in the numerator and 12 to the 1/2 power in the denominator. So if you want to convert to radical form, in this case, I think that would be easier, especially since we're so used to simplifying square roots. And because it's not a perfect square, we're just going to be following our simplifying radicals rule. So the perfect square factor of 12 is 4. So this turns into 1/2 times the square root of 3. And then I'll rationalize my denominator and get the square root of 3 over 2 times 3, which gives me 6 in the denominator. Now I can't simplify this because in the numerator that's under a radical, and in the denominator it is not. So that is my simplified form. My next example, I am going to distribute my exponent. Power of a power rule is you multiply your exponents. So 1/3 times 6/5, I'm going to cancel my 3 and 6 to get 2/5. So this is 243 to the 2/5 power. So this is where I'm going to follow my steps. I'm not going to convert to radical form. I'm going to use the denominator as a root to make my numbers smaller. The 5th root of 243 is 3. And then 3 squared, now I'm going to use my numerator as a power, gives me 9. And my last example, similar to the first one, they've got the same base, so I'm going to go ahead and simplify them inside the parentheses first. So 27 to the 1st power divided by 27 to the 1/3 power, subtracting my exponents, I get 2/3. And because I know that 27 is a perfect cube, I am going to continue simplifying it inside my parentheses. So the cube root of 27 is 3. So now I'm going to go ahead and distribute my power, multiplying my exponents together. And the negative means it goes in the denominator. So I'm going to take the whole expression, move it to the denominator, and my exponent becomes positive. So the way that I'm going to finish simplifying this is actually I'm going to leave it as 3 squared. So I'm going to turn my denominator into a root for similar reasons on the first example on this slide. And the way that we rationalize when we have a root other than a square root is, remember, we need 3 3s in order to cancel with that cube root. So I've already got 2 3s under the radical, so I'm going to multiply by 1 more. So in the numerator, I have the cube root of 3. In the denominator, if we multiply, we'd have 3 squared times 3, or 3 cubed, which will cancel with my cube root, leaving me with a 3. Again, I can't simplify this any further because the 3 in the numerator is under a root, and the 3 in the denominator is not. So here are your U-try problems.